The next important circuit analysis technique is source transformation. So what happens here is, if you consider a voltage source in series with a resistor. Okay. Now take this to be Vs and this to be Rs. Now this you can convert into a current source which is in parallel with a resistor, with the same resistor. That means Rs will be here. What about the current value? Here if Is is the current value, this is related to where Is is equal to Vs by Rs. Okay. So this is Vs and this is Rs. So this current source will be equal to Vs by Rs. That amount of current this current source is going to deliver. Okay. So we can verify this as well. If you take this as A and B, then this as A and B. So if both these circuits are equivalent, then what it means? They are going to give the same voltage and same current. Okay. So if the voltage here is V1, then voltage here also should be V1. This is terminal A. And if the current here is I1, then the current here is also I1. So you can verify this. What is the voltage V1 from this? V1 is equal to Vs minus I1 Rs. And what about the voltage here? This is going to be V1 is equal to the current through this into the resistance. What is the current through this? Is minus I1 into Rs. What is Is? It is Vs by Rs minus I1 into Rs if you take. So you're going to get the same value that we have here. Okay. Similarly, you can see that the current delivered is also the same. Okay. So this should be the condition. And here Rs resistance should be of the same value. Now what about from here to here? Okay. So that means if Is and Rs are known, then resistance anyways it is going to be the same. What about Vs? If the conversion is from current source to voltage source, okay, then Vs is simply going to be Is into Rs. This is the conversion that you have to do. Okay. Now what about dependent sources? Can we perform source transformation on dependent sources? Source transformation on dependent sources. So yes, it is possible, but there is a point that you have to remember here, one very important point. Let us say there is resistance and the voltage source is a dependent voltage source. Okay. Now this resistance, if you take Rs, and the current through it if you are taking as I0, and the voltage source is dependent on this control variable. That means it is giving out some 4 I0, let us say. Okay. So Vs is equal to 4 I0. In this case, you cannot perform source transformation. Cannot perform source transformation. Okay. So as long as we are not transforming the variable itself, then it's okay. Okay. What is another? Let me take another example where it is possible to do the source transformation. So there is another resistor here. Now this is Rs and the voltage across this we are taking as V0. Okay. And Vs is equal to 4 times V0, let us say. Okay. Now these two we can apply source transformation. Okay. So that means we can replace this with a current source in parallel with a resistance. Okay. So what will be the current value here? We will see this resistance is going to be as it is, and this current source now it is going to be equal to Vs by Rs. That means 4 V0 by Rs, and here you have voltage. Okay. So this you can do, but here we were not able to do because once we transform, then this control variable will be lost. Okay. So that is why make sure that the source transformation does not affect the variable, the controlling variable. Then you can apply it on dependent sources as well.